In this lecture, we will discuss about third fundamental theorem. So we start third fundamental theorem. So the statement of third fundamental theorem is, let G be any group and H be any subgroup of G, H be any subgroup of G, and N be a normal subgroup of G, normal subgroup of G. So then H n over N is isomorphic to H over H intersection N. Now we shall prove this theorem. So for proving this theorem, we write if H is a subgroup of G, because in statement already given H subgroup है और N normal subgroup है, means X H X inverse. So X N small n here we consider as X inverse belongs to N, X belongs to G. तो आपको सबग्रुप की डेफिनेशन भी पता होनी चाहिए, नॉर्मल सबग्रुप की पता होनी चाहिए, और आपको कोशेंट ग्रुप की भी डेफिनेशन पता होनी चाहिए, फर्स्ट फंडामेंटल थ्योरम भी पता होनी चाहिए. We have already discussed in previous lecture. So now, if H is a subgroup of G, H is a subgroup of G, and N is a normal subgroup of G, N is a normal subgroup of G, so then we know that H intersection N is a normal subgroup of H, is a normal subgroup of H, and H over H intersection N is a quotient group, is a quotient group. Now, similarly, we write down as Hn is a subgroup of G, Hn is a subgroup of G, Hn is a subgroup of G, and N is subset of Hn. Since N is a normal subgroup of G, N is a normal subgroup of G, so then N is also a normal subgroup of, also a normal subgroup of Hn. So N is a normal subgroup of Hn. So we can say that H n over n is a quotient group, is a quotient group. So now we define a function. So after defining these things, we define a function. So now we define a function phi from h to hn over n. So by setting, we define the function phi of x is equal to nx. So here the x which belongs to h. So this function we have defined. Now we shall prove that the function is well defined or not. So for proving function is well defined, so first we shall prove that function is well defined. Phi is well defined. So for proving function is well defined, so we consider x and y be two element of h. So we take as x is equal to y. So when x is equal to y, so this can be written as nx is equal to ny. So nx is equal to ny because x or y belongs to h. So we can write down as nx equal to ny. So nx equal to ny, so that can be written as phi of x equal to phi of y. So this we can write down by using the definition. So this we can take as the definition. So function is well defined. Phi is well defined. Means function is 1 1. Now next we prove that phi function is homomorphism. So second part we take as function is homomorphism. Function is homomorphism. So for proving homomorphism, we take again two element. Let x or y be two element of H. So we can define as phi of xy, phi of xy equal to nxy. So this we write down by using the definition. So because we have defined the function phi of x equal to nx. So this nxy can be written as nx into ny because n is a normal subgroup of G. So ये normal subgroup की definition से normal subgroup of G. So this we can write down nx into ny. So this nx can be written as phi x or ny can be written as phi y. So we use the definition. So by definition we write down this as so function is homomorphism. So we can say that phi is homomorphism. Phi is homomorphism. So after proving function is homomorphism, we shall prove that function is onto. So third part, we shall prove that function is onto. So phi is onto. So for proving phi is onto, so we take the element of hn over n. So let we consider the element nx which belongs to hn over n. Hn over n. So here we can write down this x. So x belongs to hn. This n also work as identity, you know. So now we consider element x. X we can take as x equal to hn. We can consider as x equal to hn. So for some h belongs to h or n belongs to n. Again, we can consider as h dash n dash. Yeah, for some h dash belongs to h or n dash belongs to n. So we take the different elements. So now because we have written that x belongs to hn. So now we consider at phi of h dash. Phi of h dash. So phi of h dash which equal to by definition. So n of h dash. So n of h dash. So this n of h dash can be written as n into n dash into h dash. We can write down this by definition of subgroup. सबग्रुप की एक थ्योरम पढ़ी होगी आपने एच एच इक्वल टू एच एच इक्वल टू एच तो दिस एच बिकॉज एन इज ए नॉर्मल सबग्रुप तो बी ऑल्सो सबग्रुप So that h can be n can be written as n into n dash because n dash belongs to n. So now we can write down as this n dash into h dash, n dash into h dash, this is equal to x. So this can be written n into x. So here we have n dash belongs to n. So with this equal to nx, so that means nx be the element which belongs to hn over n. So we can say that function is onto. So phi is onto. So phi is onto. Now we shall prove that fourth part. The fourth part is kernel. Kernel phi is equal to h intersection n. So kernel phi is equal to h intersection n. Now, so we consider a element h which belongs to h. So we write down such that h belongs to kernel phi. H belongs to kernel phi. So we can write down as phi of h is equal to identity by definition of kernel. So this can be written as phi of h by definition phi of, ये तो कर्नल की डेफिनेशन से लिख दिया. अब phi h को क्या लिख सकते हैं? Phi h we can written as nh. तो nh is equal to n. ये हमने फंक्शन की डेफिनेशन से. So by definition of phi. So by definition of phi. So here n h is equal to n. So यहाँ से हमने फिर अगेन इसी डेफिनेशन को यूज करेंगे. क्या है हमारी एच एच इज इक्वल टू एच एच इज इक्वल टू एच. तो दिस स्मॉल एच बिलोंग्स टू एच. तो यहाँ पे एन एच इक्वल टू एन. सो दिस एच बिलोंग्स टू एन. सो दिस एच belongs to n. So we can write down as h belongs to n. So h also belongs to h intersection n. So h belongs to h or h belongs to n. So h belongs to h intersection n. So we can say that the kernel phi is subset of h intersection n. So this is our equation number 1. So again, let x belongs to h intersection n. So this can be written as x belongs to h and x belongs to n. So now we write down as phi of x. So phi of x is equal to nx by definition. So phi of nx, this nx we can write down as equal to n. This we can write down equal to n. So x phi of x equal to n. So phi of x equal to n. It means x belongs to kernel phi. जो पहले हमने किया यहाँ पे phi of h equal to n. So this nx can be written as n. So x also belongs to h or x belongs to n. So by definition again, so we can write down as x belongs to kernel phi. So here you can say that x एलिमेंट किसका था? h इंटरसेक्शन n का. ऐसे एलिमेंट किसका है? कर्नल फाई का. तो यहाँ से क्या हो गया कि जो h इंटरसेक्शन n इज द सबसेट ऑफ कर्नल फाई. मतलब सारे एलिमेंट h इंटरसेक्शन n के बिलोंग कर रहे हैं फाई को भी. दिस इज अवर इक्वेशन 2. तो 1 और 2 से कर्नल फाई सबसेट है इसका और यहाँ पे h इंटरसेक्शन सबसेट कर्नल फाई का. दैट मीन कर्नल फाई is equal to h intersection n. So kernel phi is equal to h intersection n. So we can use the first fundamental theorem of homomorphism. So here we can write down by using first fundamental theorem. So by using first fundamental theorem on homomorphism, Hn over n is isomorphic to h over h intersection n.